Heat engine is a system that converts heat into mechanical energy. And it consists of basically three parts. One is source, that is reservoir at higher temperature, say TH, and reservoir at lower temperature, that is cold reservoir you might say, or sink. In between the two we have working substance. Working substance could be steam or gas or some other type also. With these three parts of heat engine, the whole working could be easily understood. You see, from source at higher temperature, heat is taken. Heat is absorbed by the working substance that basically uses this energy in doing work, in expanding. Then some energy is utilized in doing work, and what remains that goes to cold reservoir, or you might say sink, that is at lower temperature, that is known as sink or cold reservoir. Then you could say the whole process has taken place in steps of a cyclic process involving two isothermal, two adiabatic. And the efficiency of the heat engine is basically defined by the relation in which we use work done upon the heat absorbed by the working substance from the source at higher temperature. Working is, you see, QH minus QL upon QH. You could say the efficiency depends on the work done by the working substance and the heat received from the source. It could also be written as in this manner. However, whatever efforts we make, but this is just impossible to get the efficiency equal to 1, because the two amounts of heat transactions could never be equal. One has to be basically different. Whatever is the value of QH, QL that is transferred to the reservoir is certainly less than the heat that was absorbed from the source. So, it's never going to be 1, never going to be 0. In that case, it's always efficiency can never be equal to 1. If it is 0, then only it could be equal to 1. So, that way we could say that efficiency of heat engine can never be equal to 1 or 100%. As far as the temperature are concerned for the two, that is source and sink, we could also write the relation this way: T1 minus T2 upon T1. This is higher temperature, this is lower. This could also be written as 1 minus T2 upon T1. So, basically we are having two relations for efficiency of heat engine. Heat engine can never be 100% efficient, but that means it is not in a position to transform the heat completely into work. These things have been clearly mentioned over here.